Hello, this is Mrs. Ellsworth, and this is a tutorial on negative exponents. This is Chapter 3, Section 4B, assignment, and it's on negative exponents, but I thought that we would first talk about a couple of positive exponents that we know and come up with a pattern so that we can understand what negative exponents are. So here we go. We've got up in the top here, we've got 10 to the fourth power, which we know is 10,000, and 10 to the third power is 1,000. And 10 squared would be 10 times 10, so it's just 100. And then 10 to the first power is itself. 10 to the 0 power, if you remember right, anything to the 0 power is just 1. And then 10 to the negative 1 power would be a tenth, so you move the decimal over just one more because we were following that pattern where the decimal is just moving over one, but we'll write it as a fraction as 1/10. Then if you think about the 10 to the negative 2, let's go down here. And 10 to the negative 2 then would be 1/100th. So before I talk about anything here, I want to go and talk about the 2's, and then we'll come back to that. So with the 2's, we know that 2 to the fourth power is 2 times 2 times 2, so it'd be 16. And 2 to the third power is 8. 2 to the second power would be 4. 2 to the first power itself. 2 to the 0 power again is 1. And then now what happens? Well, look over here. We went and put 10, so it's just going to go under 1. So it's just going to be a fraction of 1/2. So now when you really think about this, here, let me see if I can get this to write with my finger here. This is really 1 over 2 to the first power. Okay, so there's a relationship between this one and that one. Let's go over and look at those 10's now also. Those 10's show another one because this is really 1 over 10 to the first power. And then we've got 1 over 10 to the second power. So if you'll notice, there is a relationship here. Here's 10 to the negative 2, and then we make it 1 over 10 squared. So there is a relationship there. Let's look at this one more way. Let's find another relationship. So we've got here a situation where I've got 4 to the third power, 4 to the fifth, and we know how to write that in expanded notation. Okay, and then so it's just 3 4's on top of 5 4's. Okay, then what is the quotient of that? Quotient means the answer to a division problem. So we would do some canceling out there. If you can see this here. You would do some canceling out to where 4 goes in there one time, 4 goes in there one time, and so on. And so then we would get the fraction of 1 over 4 times 4, or 1 over 4 squared. Okay, now on the bottom left over here, okay, what does 4 to the third over 4 to the fifth equal? And we'll do our subtraction that we know how to do from our last unit. So it's really 4 to the 3 minus 5, so it's going to really be 4 to the negative 2 power. So what we've been coming up to this whole time, these things right here, okay, that they've got a relationship. And here's that relationship. We've got 4 to the negative 2 power, and that really equals 1 over 4 squared. So that's a pretty neat way of looking at it, that it is actually a property in math, and it's really a way of expressing that what's the rule of negative exponents? Is any non-zero number, first of all, that is raised to a negative power is really the inverse of that power. So I'm not going to write that all out here. You can go ahead and rewind it. So is any non-zero number that's to a negative power is really the inverse, the multiplicative inverse, or else the reciprocal of that number in a positive power. So let's go and do some examples here. Okay, so let's go ahead and look at the example number 1. We've got 6 to the negative 2 power, and again, that means we put it over, we put it into the form of a fraction, so it's going to be 1 over 6 to the 6 squared. Okay, notice that it just went downstairs, and now we took off the sign there. Okay, then we've got x to the negative 5 power, right over here, and then it's going to be 1 over x to the 5th power. Again, this now goes downstairs, but we make that a positive exponent there. Okay, now you try with the bottom two. Go ahead and pause and write them down, and then check your answer. Okay, so we'll put we'll put 5 to the 6th power under 1. Okay, and that's all that negative exponent equals. Now we've got t to the negative 4th power, so that will go in the denominator of a fraction as being 1 over t to the 4th power. Okay, now we can do this, but read this instructions here. Write each expression using a negative exponent other than -1. So they don't want to see this. Okay, so we got to figure out what are they looking for. Well, really 9 is a perfect square down below. So it's really 1 over 3 squared. So now we can do it with an exponent other than a -1, which would be 3 to the negative 2 power, excuse me. Okay, example 4, we should recognize that from the first page, but we're just going backwards a little bit here, like example 3. So now it's just going to be d to what power? It's going to be d to the negative 5 power. Okay, now this letter C you tried is just like example 3, and then letter D is just like example number 4. So pause it and go and do those. Okay, here are the answers. So we've got 1 over 16, and so they don't want an exponent of -1. So 16 to the negative 1 power is not what they're looking for, and that'll be wrong. So if you recognize that 16 is a perfect square, it is really 1 over 4 squares, so it'd be 4 to the negative 2 power. But perhaps you saw that 16 was also 2 to the 4th power, and that would be perfectly fine too. And so it'd be 2 to the 4th power, so then that would be, oh brother, hold on here. Okay, so then we'll have 2 to the negative 4 power. Okay, so moving on to the next problem. It would be t to the what? It'd be to the negative 6 power. Okay, now we're going to have to start using some of those negative exponents and see, you know, like in the example number 5, we have to add exponents whenever they are multiplied. So when we add exponents, we now need to consider when it's a negative integer. So we've got x to the 3 plus a negative 5. Okay, and so that's going to be x to the negative 2 power. Okay, or we could go and put it in the denominator by being 1 over x squared. Okay, next we've got just a division problem, just like what we had on the last assignment. And so we've got g to the 5 minus 2, because in division, again, we subtract. Okay, and so we've got g to the 3rd power. But what if we had those denominators and numerators? What if there was something negative in them, or if they were switched around? If they were switched around, it'd be like g squared over g to the 5th, and then you would find that you would go and take 2 minus 5, okay, and so when you subtracted that, hold on here, you would get g to the negative 3, or 1 over g cubed. Okay, so that's how those work out. Okay, let's look at the next example. Okay, we've got x to the negative 2 over x to the 1st power. First of all, you could go and stick that x to the 1st power up here and the x to the negative 2 down here. You could go and put them, if it's in the numerator, you can put it in the denominator and get rid of that negative exponent, or you could just go and write a subtraction problem with the rules that we already know. Okay, and so that's going to be a negative 2 minus a negative 1. Okay, and so you know also that we're going to add the opposite. And so we would get x to the negative 1 power, or 1 over x. Okay, and then you try it with the last one there. Pause it. Okay, c to the negative 4 power, and then we're going to subtract 3. Shoot, I made a mistake here. We're going to add to this one, so let me get that right there. So we're going to add 3 to it. So now it's really, so negative 4 plus 3 is really c to the negative 1 power, or what? 1 over c. And so that's our answers. So then when I see you the next time, I would expect you to have problems numbers, the evens of 2 through 46. And then I assigned 3 extra credit problems of that, so it's not so bad. And I will see you when I see you. If you have questions, come see me in the morning, please. And you have a good night.